everybody, my name is Erick Fejta, and I am here with the engineering productivity team at Google. And we get to work on some of the tools that help communities like Kubernetes, Istio, and Knative stay productive. Um, I'd like to talk about two of these tools that we work on today, Prow and Testgrid. So Prow is an eventing system that lets you do important activities like continuous integration testing and continuous deployment using some common patterns like GitOps and ChatOps. Testgrid, on the other hand, is a way of visualizing your current and recent test results. This sort of makes it easy to detect patterns in your testing that you might want to investigate further. We're going to talk about both of these tools, of course, and hopefully I'd like you to sort of see what they look like, see how they're useful, understand how we develop and maintain them, and maybe try them out yourself. So let's start with Testgrid. You can see the code for Testgrid over at Google Cloud Platform Testgrid in GitHub, or you can go to testgrid.kates.io to see our public deployment. When you go there, you will start off by seeing a dashboard, sort of a grid of different dashboards that you can go to, or potentially a group of related dashboards. When you open one of those groups, you will first start out with a summary of that group that's sort of showing you all what's been recently happening with each of those dashboards. Open up a dashboard and you'll get to the summary of all the different tabs of testing that are happening on your dashboard. When you open one of those tabs, you'll get to the grid where you'll see rows of testing flowing down and columns of results flowing to the right. The cells are colored based on whether they pass or fail, with green meaning pass and red meaning it failed, and maybe if something interesting happens, it'll be another color. This sort of, is the ideal state. Obviously, most likely you'll have more tests, and this will make it hopefully easy to see sort of some interesting patterns that happen. Like here you can see that there is a regression in some disk testing in November. Or it might be, get considerably more complicated over time. The way you declare these jobs is with sort of a YAML document. We find this to be a really easy pattern that's for people to understand, which helps teams onboard quickly, which we like because it feels good for the team to sort of be able to onboard quickly without having to wait for us to explain things to them or give them permission. And the time we're not spending helping supporting these teams is time we can spend making the next version of Testgrid even better. So here's what this definition looks like. You define one or more test groups that reference a Google Cloud Storage path. And inside of that path, you will have each column is represented by a monotonically increasing number that sort of acts as a directory. And inside each of those directories, you'll have some metadata, like a started and finished JSON file that specifies what was checked out, how long it ran, whether it passed, those sorts of things. And optionally, some JUnit XML files that give you more details about exactly what testing happened and the results during that build. Once you have your test groups defined, you then have to put them into one or more dashboards. And typically, each test group will only have a single tab, but you actually can have you can have a test group be referenced by multiple different tabs. This can be useful if your testing is owned by multiple teams. So for example, in the Kubernetes community, we have a lot of large end-to-end tests that tend to be we sort of tend to deploy a cluster once and then run everybody's tests inside that same cluster. But individuals tend to only be interested in a particular sub area of Kubernetes. Like maybe one person's interested in the storage features and another person's interested in the networking features. So we'll give them a sort of view that pares down the testing to just the storage or just the networking tests. Maybe a third that has all of them for when that is important. There's a lot of different ways to configure Testgrid. You can look at our documentation that sort of gives you all the different knobs you can tweak to make sure that your grid looks exactly the way you want. And so, a lot of the stuff you can configure, you can declare in your configuration, but then there's also a lot of flexibility at runtime. So for example, there's the size drop down to customize the width of each cell or column. And then there's the options drop down that will let you filter down to just the tests that are relevant to whatever you're investigating at the moment, or maybe group them into some kind of hierarchy, or maybe change the sorting to highlight particularly flaky tests. If you have numeric data, you can graph that and potentially see interesting patterns there that have been happening. Like maybe there's been a recent performance regression, and you can sort of figure out exactly what commit or when that happened. So yeah, so as you configure things, that information gets bubbled up into the summary. So this will highlight tabs that it thinks are broken, or sort of give you all sorts of interesting information, and this will help you optimize figuring out where you should be investigating your time into looking into what's happening with your system. So yeah, so we talked about how the YAML declarative YAML pattern is helpful for people. Is helpful for us, keeps us and them productive. Another thing that helps us stay productive is using Kubernetes, which is where we deploy Testgrid into, and in particular using GKE Autopilot. So this is a new way of running a Kubernetes cluster that sort of makes all of the nodes invisible to you. So we really like this because it frees us from having to worry about exactly how many VMs we want to use, or what OS they're running, or how many CPU or how much RAM to put on those VMs. Instead, we can just declare that in our deployments. We can specify like how many replicas we want, how much RAM and CPU these jobs require, and GKE Autopilot makes sure that the cluster is sized appropriately to handle my jobs. This is really great because we don't really want to be, all the node management is sort of hassle that we don't want to have. And so it's been really nice not having to worry about that. Another thing that helps us be productive is, of course, Prow. So so we use Prow in all sorts of different ways. We use it to test new changes that come in to make sure that they're not regressing anything. We also actually use Prow to merge our tests merge our changes once they've been reviewed and passed testing. We use it to publish new images and also upgrade our production environments with those new versions. So let's see how that looks. You can look at the code for Prow in the Kubernetes test infra repo on GitHub, in particular the Prow directory there. You can look at one of the public instances at prow.k8s.io, or you can see a bunch of other ones in the README. Prow sort of came out of the Kubernetes community, and you can see that its influence in a lot of the design decisions that Prow uses. So one thing that's a pretty useful and powerful feature about Kubernetes is that it has custom resources, which allow you to extend your Kubernetes cluster with new types of objects to manipulate. So instead of just having the services and deployments that come with Kubernetes by default, we can also add so Prow sort of extends it by adding a Prow job resource. So this is showing you how that is declared. The interesting thing about that is it becomes the pattern, like sort of the Prow job becomes the sort of glue that all the different components of Prow use to communicate with each other. So they communicate by reading from and writing from a Prow job via the API server rather than talking to each other directly like an RPC. So this sort of creates like a loose coupling of the system that allows for more flexibility in terms of how we deploy and maintain the service. So for example, there's less availability restrictions since, since one component isn't talking directly to another component, if there's a brief outage of the other component, that doesn't prevent the first component from working. If you look at the history of Kubernetes design, you can see that it tries to be tries to be inspired by jazz improv, where you have a bunch of talented performers that are following some, some rules to create interesting music. But there's no central coordination like you would have in the symphony orchestra, for example. To see this working in action, if you want to do some testing that's going to, in response to some GitHub event, that'll use the hook component. So hook is going to be receiving your webhooks from GitHub, and then it will respond to that by creating a Prow job. And it does that by talking to the API server. Then the Plank component it's sort of watching and listening for new Prow jobs. And when the API server tells it about a new Prow job that exists, Plank is then going to read the config and create the corresponding the corresponding pod to complete that job. And then it'll update the Prow job status to, when the pod starts and finishes, to let everybody else know what is happening there. So with pre-submits, so to do pre-submits with this, you're first going to need to configure the hook plugin, configure the trigger plugin on Hook. Hook has a bunch of different plugins that you can look at. Sort of encourage you to take a look at the different plugins that we already have built into Prow, or if there's some new thing that you would like to do, you can write your own plugin that satisfies that. And then once you've enabled the plugin, you then declare your jobs in YAML, sort of to specify what happens. So let's take a look at what one of those looks like. Here is the pre-submit for Testgrid, and you can see that it's sort of divided into two sections. The top section is mostly about the triggering, specifying when the Prow job should get created. You can see that it's targeting the Testgrid repo, and that it's a pre-submit, meaning it should run before code merges, and it's sort of targeting the master branch. Then on the bottom, you have the Kubernetes pod spec. So another interesting aspect about Prow is that it uses pods directly. Like, it doesn't have its own runtime environment. It just creates the pod that you specified and waits for that to complete. So it really, expects you to understand how Kubernetes works. So all the knowledge that you have about Kubernetes already, you can transfer into writing your Prow jobs. Or conversely, if you're using Prow to gain new expertise about Kubernetes, all of that will transfer to the other ways you use Kubernetes. But the sort of, really simple version is that you need to have a container, and that container will specify a Docker image that provides its runtime environment with all the dependencies your testing needs. And then there's a command that'll be run inside your container. And so Prow expects your command to exit 0 if your testing is successful, and exit non-zero if something failed. So another couple things that help us be more productive is workload identity and decoration. So if you notice, when we declared the pod, we specified a service account to use inside of this job. And workload identity is a GKE feature that allows us to annotate the service account, telling GKE who we want this service account to authenticate to GKE as. And this works really great for us because it allows our code inside our testing to not have to worry about authentication. It kind of just happens automatically in the background via workload identity. And so we can just have our testing, focus on testing, not have to worry about authentication. The other thing is decoration, which is telling Prow that when it creates the pod, it should inject some init and defer containers. These containers sort of run before and after your test containers, and they'll do some common boilerplate work, like making sure that all of your repos are checked out at the right commits. And then it'll also upload the metadata about when it started and when it finished, and it includes a artifact volume where you can copy all of your JUnit XML files into. And Prow will make sure that, or the Prow will make sure in the defer container to copy all those up to GCS. So for things like publishing images or upgrading our cluster, we're going to want that to happen after merging code. So that's going to be a post-submit job, and this sort of gets into the GitOps side of things. But aside from but otherwise it's really very similar to the pre-submit. Here's what it looks like. Instead of a pre-submit, it's a post-submit. But otherwise the trigger is very similar. This is just saying that we want it to run after we merge code. And then if you look at the pod, you can see that it's also very similar, but we've provided a slightly different image to use and running a different command. And also see that we're using a different context. Since this is pushing images that we intend to use, we want it to run as a more trusted user. So we have a different service account. We obviously don't want our pre-submits pushing images. And then we'll also have the ability Prow has the ability to schedule the pod into different contexts. It can be a different namespace, or it can even be a different cluster altogether. Yeah, so that sort of is how pre-submits and post-submits work. If your testing needs to run according to some kind of schedule, like a cron job or whatnot, that will be handled by the horologium component. And so obviously everybody knows that the horologium is the clock constellation. So once we publish new images, we need something to notice those new images and upgrade our cluster to them. So we use a periodic job for that. And you can see here we're scheduling it to run on a hourly basis during working hours. And then let's see, you sort of provide the configuration about under what types of images it should be bumping, and then this will run and then notice find any new images that exist, and then automatically create a PR to update our images to use the new versions. It's kind of nice because it makes it really easy to see what changed in our images between the last and current version. And then once we've approved it and merged it, we now need something to actually deploy it to production. That's going to be and so we're going to use another post-submit job for that. Looks largely the same, just with a different image. Yeah, but otherwise just another post-submit. So great. So sort of in summary, we sort of showed you how Prow. How we use Prow to test Testgrid, publish it, publish new versions, and then upgrade our cluster. Then we also talked about how Testgrid can help you visualize testing that has been happening recently for your system and find interesting information. If you are wanting to try either of these things, you can go to our Getting Started Deploy documentation for Prow, and then look at the standalone Testgrid documentation. If you go to this link here, the testgrid.kates.io/r/knativeown Testgrid, you can see an example of what this will look like. We also have contributing documentation if that kind of thing is interesting to you. We'd love to hear from you, or and so please feel free to reach out to us. You can contact us either via Slack or GitHub. And so that sort of concludes my presentation of Prow and Testgrid. And so thanks for joining me, and have a great day.